Please welcome to the stage Professor Mauritz Kop, founder and executive director at Stanford Center for Responsible Quantum Technology.
These are the colors of infinity, beat synced to human and machine-created music, with you, the audience, starring as input data. You can think of fractal geometry as a metaphorical secret code of creation, long hidden for its complexity, a message built into numbers, a God equation. I find it a great tool to arouse my brain and to ignite creativity beyond daily sensory experiences. You'll subconsciously recognize many of the shapes as nature uses fractals in its workings. In DNA, planets, animals, our body's organs, our brains, clouds, planets, solar systems. There are repetitions, iterative combinations of chaos and predetermined form. The apparently random forms that exist in nature. They trigger a resonance in the brain. Fractal formulas bring order to chaos. Fractal geometry, as an extension of Euclidean geometry, stands at the basis of the code, the numbers and algorithms, the visuals before you run on. It deals with how things are shaped. Fractals go on to the infinitely small, down to the Max Planck length, to the quantum level. My intuition tells me these fields are connected. In fact, fractal geometry and their patterns have recently been discovered in quantum materials such as neodymium nickel oxide, complete with eccentric, paradoxical behavior. We are all walking quantum computers. Quantum phenomena create conscious experiences. A new theory called holography is the idea that there are different descriptions of our reality besides Einstein's general relativity, suggesting that there is a deeper theory of our experience of the world that does not have space and time in it. Beyond the legacy way of processing information classically, we found a new method, a novel computational paradigm, a new way of reasoning, quantum information science. This new way of reasoning is so powerful that many are convinced it is the very logic behind the fabric of our universe. Quantum processes are the ones on which nature at the subatomic level works. Take photosynthesis using quantum coherence, or quantum biology that studies the hidden nature of nature. Even space-time is expected to be quantum. So how is quantum physics related to quantum geography and quantum geometry? Quantum states are mathematical entities that contain a probability measure, a prediction of the knowledge, the information in a quantum system. Fractal geometry, as showcased by these visuals, is related to the transition interface of quantum state to classical state. That transition bridges the large and the small, as in a continuum. It seemingly connects the unorthodox quantum world with the classical, relativistic, Newtonian physics world. Fractals are applied in many of the same fields we are seeing second-generation quantum and quantum AI hybrids being applied to. Healthcare, defense, data science, metrology, chemistry, material science. And I can see many parallels in many dimensions, both in art and in societal application, which must be further studied in multidisciplinary settings. Both languages can be used to describe our universe as instruction sets, as maps that are the treasure. What I am certain of is that quantum and fractals, chance and predeterministic laws can live together. They are compatible. Yet how fractal geometry and quantum mechanics relate to each other is still very left open and mysterious. Perhaps we will see counterintuitive quantum mechanical properties and effects like uncertainty, probability that become unavoidable below the 10 nanometer scale happen in the beat-synced visual overlays in our classical world when I feed audio-visual input data to the machine that trigger the fractals in real time. Fractals are where math, infinity, classical physics, and quantum mechanics meet. Behold our fractal cosmos on the screen. The marriage of mathematics and art gives birth to the mesmerizing magic of fractal art in an endless series of motives within motives. My creative machine visualizes infinity at all scales, while processing dynamic art beyond verbal description, representing musical notes as locations in space. It runs on the same GPUs as generative AI, and programming these overlays can be immersive, as everything looks so familiar, and one tends to keep searching for more variations on a theme. Almost as tantalizing as composing, as producing the music with my vocalists. Nature has chosen fractal geometry as a technical help in accomplishing its goals, as a semaphore of the physical world, how it tells itself how it's supposed to be. The human brain might have cells that handle fractal complexity, and we can activate those by ingesting fractal art as we sit here today. Fractals correspond with our mental setup. Now, how does art inspire science? By integrating art into science, we better understand the interrelatedness of everything we learn. Art enables scientists to paint abstract ideas in a tangible form. The ability to visualize and imagine is important to solve scientific problems. Lateral thinking is the ability to imagine solutions that cannot be arrived at via logical means. The essence of creativity. Art inspires serendipity, to discover things you are not looking for by chance. Fractals have the potential to be an exciting way to visualize quantum information that bridges art, science, and nature itself. This exemplifies how art can foster quantum literacy, quantum intuition, to help building a double-educated quantum workforce. In the post-truth era, we need revolutions in thought, accomplished in symbiotic interdisciplinary environments. Let us call here, at the Quantum Global, the XPANSE Forum for making transformative creative approaches a guiding principle for organizational, scientific, and cultural development of the United Nations International Year of Quantum Technology. Thank you.